Hey everyone, welcome to Dr. Frank's Finance World. I am Dr. Frank, and we have a special series here on time value of money. So time value of money is very important in the world of finance, and it's generally a three-step process about finding the value of something at a specific point in time. That's actually what finance is. We try to find the values of things at different points in time. So there is a rule, we'll get to in just a second, called Rule of 72, but it is about saving yourself. It's how you can find out kind of the general value of some of these problems before you punch it into a calculator. And that's helpful to keep you in the ballpark when it comes to testing and so forth out there. Problems. We're going to do problems on here. I'll try to include some problem sets as well, some of them for sure with answers. But anyway, it helps to do a bunch of problems. In the end, that's how you find a comfort level with this, is to solve for different things. So when you see it in the real world or on a test, you can actually find it. And finally, there's a shorthand I use every single time I've had thousands and thousands of students, and I'm sure 1,000+ problems I've done on this before. And every single time I actually take what is the BA2+ calculator, and I take the row that represents time value of money, the N, the I, the PV, the payment, the future value, and I transpose it, I flip it. And I use it as sort of an algebraic method way of writing everything down and figure out what's left to solve for. And that will help you when you get to problems out there. So. Anyway, saving yourself, rule of 72. It is true. If you can take 72 and divide it by the I out there, you can actually take how long it takes to double or halve. So basically 72 divided by 9. So if you take 72 and you divide it by the I, in this case I use 9, it takes 8 years. 8 years to double or halve your money. So it's traveling up and down this line, if you will, a timeline at 9%. And at different points in time, you can figure out what it's worth. So in this case, if it was 9%, you would expect to double or halve your money. Double it when you're going out and halve it when you're coming back. So at 7.2%, it would take 10 years to double or halve your money. So why halve? That's because of this equation down here. The future value of something is the present value times 1 plus the interest rate for a period of time. If you were to solve that for the present value, you would find out that the present value is equal to the future value divided by 1 plus I for whatever period of time you were doing. So it works whether you're moving forward or backward in time. And there it is once again. The future value is equal to the present value times 1 plus the interest rate you earn for however long you earn it. Mathematically, if you want to put it into an equation, you could take a dollar, for instance, if you're trying to see how much a dollar would be worth in the future. A dollar is the present value. 1 plus 0.09 or 9% is the interest rate. And you take it to the 8th power. And you could actually do this by using the y over n part of your calculator. But just to show you what this does look like on a time value of money calculator, and we'll get to some nuances here. If you made sure you cleared your calculator, that's the most important thing in the first step, and you had a dollar was the present value, and you were growing it at 9% was the I, and you were growing it for 8 years is the N, and you wanted to compute the future value, you'd find out that it's very, very close to $2. We'll talk about the negative and positive, but basically it's very, very close. It is a really good estimate over particular periods of time, but it will get you in the ballpark, which is the interesting part about it. And once again, graphically, in this case, we see you're going out for a number of years at 12%. If you took 72 and you divided it by 12, you would double or halve your money every 6 years. And we could do that on the BA2 plus calculator by simply coming in here and clearing it once again. That's the most important part, is to clear it out. And in this case, it was for 6 years is the N, and 12% was the I. And you had a dollar to start with. You were calculating the future value. You would actually find it is very close. A little different, not quite 1.99 like the other, but still very close to $2 out there. And that's the important part about it. So the simpler way, of course, is to use this calculator. And this line of the calculator, the N, the I, the present value, and the future value, and so forth, is the important line when you're doing time value of money. This is the professional version. Doesn't matter. It can't really do anything different than the BA2 Plus regular version. And in the regular version, the calculator is more kind of a dark brown color, and these keys are listed in white. But it is indeed the line that I flip sideways or transpose, whatever, for the N, the I, the PV, the payment future value. And also, just so you know what part of the calculator you're working in when you're doing this part of the exercise. So there, once again, are the keys I told you about. You see there in white, NIPV, present value and future value. I line those up and down just like I talked about. The N is the time on any time value money problem. The I is the interest rate or the yield that the market is looking for. The present value is the price of any of the cash flows or a future value brought back through time. The payment is important on this because a series of equal payments is the only time you can use the payment part of the calculator. That is actually called an annuity, a series of equal payments for a set period over a specific period of time. And then the future value is the future value of any cash flow. When you do a bond problem, we'll do a bond problem, and these, you still use the same keys. They're just slightly different. You know, there's many, many different ways to apply it in finance, but this is essentially the process that you use every single time. Setting the decimal places on your calculator. That's something we didn't show you what to do. Normally, if I clear this out, when it comes from the calculator, or from the factory, I mean, you will have a number of decimal places that is equal to 2. And now you see it looks like this when you come from the factory. It has 2 decimal places. I always prefer 4. The number of decimal places is important. It will round on your calculator based on the number of decimal places. And if you want to change this, all you have to do is second, and it will get you to what is above the period or dot down here format. And it will tell you that there are 2 decimal places, not 2 Decembers. And if you put 4 and then enter, now your calculator will have 4 decimal places. And I highly recommend you do it for all the problems that you'll see in time value money. So the other important thing too is interesting is the numbers stay in the calculator even after you shut it off. So let's go back to that 12% problem for 6 years. So 6 was the N, 12% was the interest rate you're making in the market. We started with $1, and then we can calculate the future value, but let's not for just a second. So if we clear the calculator and then we shut it off and we turn it back on, and then we compute the future value, the stuff we put in there before stays in there. So that's why I say it's great that, you know, it feels good to get the problems right. So be OCD and clear your calculator 4 time value money problems as many times as you want up here. You see me occasionally clear the calculator down here. What I'm really clearing is this display. We will use this function when we get to the net present value cash flow part of the lecture, but basically we're using it here to clear out the time value money keys using the clear TVM. So just a little bit of work here, problems for you. Time value money, present value to future value. John wants to borrow $100 from you and pay you back in 5 years. I hope he pays you back. If you expect to make 10% per year on your money, how much will you owe John? Well, once again, using the rule of 72, if we take 72 and we have 10% interest, it would take, or 10% interest? Yeah, every 7.2 years, you would double your money. And you can see we're not going out 7.2 years. So we know we're not going to double our money. It's going to be somewhere towards $200, but it's not going to be doubling. So mathematically, you could say the present value of $100 times 1.1 to the 5th. That's one way of calculating it. Another way would be to take 100 and multiply by 1.1 for year 1. It's worth $110. Times 1.1 for year 2, it's worth $121, and so forth until you'd grown it for 5 years. Or you could put it into your calculator, like we're talking about doing here. I'm going to clear it out first. And 5 is the N, and then you have 10% is the I, and you have $100 where you're starting with, and when you compute the future value, you get 161.05, which is what we found down here. You'll notice that the negative sign is in there. For me, and there's a lot of different thoughts on this, but for me, it recommends, sort of suggests at least, a cash flow. When we first put in this problem and we put in the present value as a positive number, that means somebody is giving us $100. So the question then becomes is how much do we have to hand them in the future if we're paying 10% interest for the 5 years? And we would have to repay them $161. Interestingly, and I would very rarely suggest you do this, but just as an example, if instead we had put in the $100 and used a negative, i.e. we invested it and it went out of our pocket, and then we computed the future value, you would find that now it's turned to a positive out here. So, and notice that I use the plus minus when I put in the 100. I can turn it to minus up here. I can make it back to plus, minus, plus, minus, plus. You go back and forth on that. You do not use the plus key on the math over here. That's not what you do. So anyway, just to show you, I typically just put in 100 and flip the negative around based on whether I'm paying it or getting it, but that's what you could do. It's probably better to look at it as a cash inflows and outflows. Finally, Jonah is considering the purchasing of a lot. He can buy the lot today and expects the price to rise to $15,000 at the end of 10 years. He believes he should earn an investment yield of 10% annually on this, and the asking price for the lot is $7,000. So at the rule of 72, if we took 72 and divided it by 10, you would know he would, just like the last problem, we'd expect him to double his money over 7.2. We're going out for 10 years, so it's going to double and a little bit more for another 2.8 years. But that's actually, if we brought it out there back through time, we're having it. So half of 15,000 is 7,500, and we're going to have it a little more than that for another 2.8 years. So we know the answer is probably very likely to be less than $7,000. But when we put that in the calculator, it looks like this. We clear it out. And then we say, okay, it is worth $15,000 in the future. And we say that it is 10 years and that it is for 10%. And if we put that in and we compute what it's worth today, we found that it's worth $5,783.15, which is, of course, what we have down here. So it's only worth this to Jonah, but somebody is asking $7,000. So should he buy it? No. It's only worth $5,700 or about $5,800. So he would be willing to pay $5,783, but he would not pay $7,000. That's how this comes into the problem. This is what somebody is asking. You have to figure out what you think it's worth before you would decide whether to pay them for that or not. An investor can make an investment in a real estate development and receive an expected cash return of $45,000 in 6 years. Based on a careful study of other investments, she believes that 18% annual return compounded quarterly is a reasonable return to earn on this investment. How much should she pay for it? When you do that, there are only, when you look at compounding quarterly out there, you're only looking at, you're changing the N because that goes from annual to quarterly. You're changing the I because you're not paying it the rate every quarter, you're paying it once a year. And you're looking at any change in payment, which there was none for this time. That's how you adjust for a difference in quarterly, monthly versus annual, and that kind of stuff. 3 things change: the N, the I, and the payment. And so when we put it into a calculator here, we would find, we'll clear it out. You had an N of 6 years, but it was quarterly, so it's really 24. You have an I of 18%, but it's actually quarterly, so you divide it by 4, and you'd use 4.5%. That would be the I. And you want to know what it's worth, $45,000 out in the future. So when you calculate what it's worth today, you find out it's only worth $15,646.66. So that is what you would actually use as the number that you're willing to pay for this investment out here in the future. So this is for non-annual adjustments. There's ones for car payments or house payments because those are monthly and so forth. It is possible to change the compounding periods, to change the P/Y. I would not do it. You're very likely to forget to change it back, and then every calculation you would use in the future is a function of quarterly, not annually. So I would be very leery about doing that. So here's a couple more problems out here. Jenny makes a deposit of $12,000 in a bank account. The deposit is to earn interest annually at a rate of 9% for 7 years. So how much will she have to deposit at the end of 7 years? So or how much will she have on deposit at the end of 7 years? So N was 7. The I she was making was 9%. So you can see she basically doesn't quite double her money if she's only going out well, be 8 years versus 7. So $12,000 is the present value of what she has to put in now. When you stick that in a calculator and compute it, you'll find it's worth just a little less than $22,000. If I knew everything now and I'm changing up the problem, but I wanted to solve for I, like we didn't know what I was, remember you can solve for N, or you can solve for I, or whatever out there. The N would be 7, the I we don't know now. You still put in $12,000 now, and let's put that in as a future value. This is an important concept here too. So when we do that, we get 7 is the N, we get 12,000 as the present value, money you put in now, and 36.47. And we put that in as a future value, and we hit compute to get the I. Bam, you get error 5. The way the calculator works is it tries to offset the present value or the cash flow or both against the future value. And what the problem is telling you when it's set up here is you're going to get $12,000 from somebody, and 7 years from now they're going to pay you another $21,900. What's your return? Ultimately, it's infinite if you think of it like that. So the way you solve for this is the $12,000 you put in initially, you put it in, right? So you put it as a minus, you put it in as the present value, and when you compute the I/Y now, you get 9%. So that's important as well. Assuming the deposit earned a 9% rate of interest compounded quarterly, which is what you see this problem is down here, what would that look like? So once again, the payment per year is 1. The N now is 28, so I'm going to clear out the problem. So it's 7 years for quarterly, so there's 28 quarters. You're going to take a 9% interest rate on this time, and you're going to do it quarterly, so you're going to divide it by 4. And now you're going to be getting 2.25% each quarter. And you start with $12,000. Now you're putting in the money, and you compute what the future value is. You're going to have $22,374. And realize that this is more. This number right here is more than what this number is here. And the reason why that is, when you compound quarterly, you make interest on interest, and it's worth just a little bit more money in the future out there. But this is how you adjust to be a quarterly problem. Well, solving for I, once again, we did the I. This is another I problem, 9% N, 100% future present value, 200 future value, make the error 5 again. Use the plus minus key to change that, just as an example. Rule of 72 says it should be about 8%. And you can do that for yourself. So finally, solving for different variables out there. Suppose you deposit $5,000 into an account earning 4% interest compounded monthly. Now, what would that look like? The N, or actually trying to find N. The N would be in monthly. The I would be in monthly. If there was a payment, it would be in monthly. But we're solving for N in this case. We don't know what it is. So we put in minus 5,000 as the present value. We put in 4% as the I. Quarterly, you divide it by 12. You put in the future value of 7,500. And when you solve this, you get an N of 121.84. So remember this, the N now is in terms of months. So it's going to take about 120 months, which is a little over 10 years. So you have to go in there and realize you have to divide this by 10 in order to figure out how many years that actually is. And when you do, you have 10.15 years. So remember, when you get inside of a monthly or a quarterly or a daily, hourly, whatever the problem, the result you're finding, if it happens to be N or I or payment, is a monthly or quarterly result. And if you want to see what that would be annually, you have to convert it back. So suppose in addition to the 5,000 you put in up here, you will make monthly contributions of $50. How many years will it take now? So the add in here that the payment is of $50 a month, so it's minus 50 you put it in. You still have the minus 5,000 you put in. You still have the N of 4% monthly out there. So you put that in, and then you calculate what the N is, and just adding a payment up here, if you will, for minus $50. You find out now it's a little less than 36 months. So it only takes about 2.95 years to get to where you wanted to, as opposed, which was $7,500, as opposed to 10 years when you didn't put any extra money in. So putting the extra money in is pretty darn helpful in this situation too. Strategy or tip for the present value to future value back out there: clear your calculator first. Always, always, always clear your calculator for the time value money function, because you'll get the answer right. And of course, use the rule of 72. That will get you in the ballpark first. Don't forget to send emails with comments and suggestions, or ask Dr. Frank so I can see what else you guys want to learn. And that's it. This is the first part of it, which is present value to back and your intro. Have a great day. See ya. Bye-bye.